Hi everyone, in this video I'm going to try to connect a bunch of different modules all together into one section. And so now that we know what acids are, I want to go all the way back to our very first module when we talked about the air we breathe, and I want to talk about our third module when we talked about global climate change. And so what we need to keep into our back of our mind is that a lot of these acids that are commonly found in nature, not that they naturally exist there, they're commonly found in nature because of our combustion reactions. So let's review from the beginning. We take a source of fuel, we treat it with oxygen, we create carbon dioxide and water and pollutants. And the two we want to focus on here are sulfur dioxide and nitrogen dioxide. So what we're going to do is talk about the acid that is formed in nature from these two products. And I'm going to talk about what happens with acid in nature with carbon dioxide. So the first thing I want to do is talk about ocean acidification, because that's one that I think is just a little bit easier to understand. So ocean acidification is simply the lowering of the of the ocean pH due to increased atmospheric carbon dioxide. Okay, so we know every single time there's a combustion reaction, we create carbon dioxide, and a lot of times those CO2 molecules are just released out in the atmosphere. Now we know as the carbon dioxide concentration increases, the temperature of our planet increases, and we have what's called global climate change. Now one of these negative aspects about it is ocean acidification. Now when we first talked about this, we just said, oh, carbon dioxide dissolves in the water and it makes it an acid, blah, blah, blah. But now you can actually understand this. So we want to go back and just very briefly talk about it. So what we were saying is that the carbon dioxide that was in our atmosphere would dissolve in water, and now at this point hopefully you know that that is going to create H2CO3, which is commonly called carbonic acid. So now we know if we add acid to just regular old water, we are really messing with the system, okay? And so what ends up happening are two major things. The first one is we have a loss of biodiversity. And so a lot of the plants that are in the ocean are very sensitive to pH. So if all of a sudden the pH starts getting lower and lower and lower, we start seeing all these different plants die off. And so currently, right now, here in about the beginning of 2016, we have already experienced a loss of 20% of our biodiversity in our oceans. We've already experienced 20%, and it's just going to keep getting worse. And that's all because we're turning our oceans into an acid, or we're making them more acidic. Okay, that's one way of thinking of it. The second thing I want to point out is that not only does it kill the plants, but it kills the fish. Okay, it kills the fish. Your fish are extremely dependent on the atmosphere, the environment of the ocean. Think about what would happen if someone all of a sudden made our environment all acidic. I mean, we'd be furious about it. It's terrible. We talked about what happens if things are too acidic and they interact with your skin, it burns. Same things for these fish. If they get into a spot where something is too acidic, it's going to hurt them and physically hurt them to breathe and to be around it. It's awful. Okay, so it's terrible, terrible, terrible. That's the first thing. The second thing I want to talk about is acid rain. Okay, and this is something I briefly mentioned in the very, very first module, but now we can come back and talk about it again. So now acid rain is essentially a rain with a pH lower than 5. Very simple. It just has a pH lower than the value of 5, so we know it's definitely considered acidic. And so just so you have kind of a ratio or something to compare it to, rain, usual rain, is normally with a pH anywhere between 5 and 6, okay? So what we're saying is that if something has a pH lower than 7, it is too acidic, and it starts changing things and having negative side effects, I should say. And so the big thing that we need to understand is that this happens from two different components. So we have H2SO4, sulfuric acid, and we have HNO3, both of which we now know are considered strong acids. Okay, so what happens is we have our SO2, which is released from coal power plants, and then NO2, which is released from a number of different things. They come together and they end up creating sulfuric acid and nitric acid, both strong acids. Okay, that's important. Keep that in the back of your mind. So now what happens when you have a strong acid and it interacts with water, like rain, right? So you have acid that just interacts with rain. We've constantly got our water cycle going through here. When it interacts with water, what happens is it breaks apart. And so now we've got all of this sulfuric acid that breaks apart into two 2 hydronium ions. Very, very acidic compounds. Same thing with nitric acid. It breaks apart into H plus and NO3 minus. So now all of a sudden, we have rain that contains H plus, pure acid, pure burning acid. I mean, it's terrible. It's so, so bad. So not only are we increasing the temperature of our planet, are we polluting our atmosphere, we are also creating acid rain. Rain that will come down on you and burn your skin off. It is not good. It is not okay. Now, I want to put a disclaimer in. The acid rain is usually not that potent that it's going to actually burn your skin off, but it's not going to feel good. You definitely don't want to be in an environment that has acid rain. So let me ask you one final question to conclude all of this. Everything that we've talked about this entire year is coal power plants, I should say, or are maybe, are coal power plants and petroleum and natural gas, are they worth it? Is this the best way for us to get our energy? Did you get an answer? I think my sad face gave it away, but the answer is definitely no. Is it worth it? Is the way that we currently get our energy worth it? Is this the way to do it? No! No! There are so much better ways to do it. We just have to keep working on the science, keep working on the technology, and doing everything we possibly can to avoid ocean acidification, avoid acid rain, and avoid increasing the temperature of our beautiful, amazing, fantastic planet. I'm going to leave you with that. Take care of yourself, study hard for the exam, and please, if you do nothing else, eat your veggies and drink your water.